Hi, this is your host Apnil Bhartiya and welcome to State of Energy. We are here at Open Sustainability Summit in Johns Hopkins University in Washington DC, and today we have two guests: Gareth Jones, Chief Operating Officer at Center for Net Zero, and Gus Chadney, Data Lead at once again Center for Net Zero. Gareth, Gus, great to have you both on the show.
Great to be here.
Hi.
It's my pleasure to host you folks here. First of all, tell us about Center for Net Zero. What is it all about?
So Centre for Net Zero is a non-profit research institute that pursuing energy systems change. So we're a team of data scientists and economists and strategists and policy advisors that working together to create an organisation that is part industry researcher, part tech startup, and part research to policy conduit.
What is the origin of the center? Is it publicly funded? It's private? It is collaboration from industry players, or it's a government entity?
Yeah, so Centre for Net Zero operates autonomously, but is actually part of Octopus Energy, which is a global group of energy businesses that has businesses across the energy sector, from generation funds operating and managing many renewable assets, billions of dollars of renewable assets, plus software licensing to utilities and energy retail as well.
Now, can you talk about your involvement with this open source LF Energy? Are you folks a member of the foundation? If yes, when did you join the foundation, and what is your level of engagement?
Sure. So we've joined very recently with a new project we created called OpenSynth, which is an open data community that we hope will democratize access to energy demand data. So we launched that community last month, and that's how we first got involved with LF Energy.
Now let's talk about OpenSynth. You briefly touched upon it. I just want to go into detail. Number one is that what is the project all about? And number two is, once again, what led to the creation of the project?
OpenSynth is a project looking to democratize access to synthetic energy consumption data. So what we're hoping to achieve is to build a community around users and creators of synthetic data. So we, as part of the Octopus Energy Group, we have access to large volumes of customer consumption data, and we use that for our research, and many others would also like access because consumption data is incredibly useful for energy systems research. And so we were thinking about how do we try and get that data in the hands of more people, and obviously there are a lot of challenges with that, particularly around privacy. And so we thought that synthetic data would be the solution to this. We actually built a tool called Faraday, which is a generative AI model that can create synthetic data from all of that real smart meter data that we have access to. And then OpenSynth came about from us wanting to take Faraday to the next level, to give access to more people. So it's not only us creating synthetic data, but others too, and building a whole community around that.
Can you just, for our viewers, explain what is synthetic data?
Sure, yeah. So synthetic data is like real data. So in this context, we're looking at smart meter data, energy consumption data. The synthetic version of that looks exactly like a household profile might be from a real smart meter data source, but is entirely fake, but has all of the aspects of real data that you would expect, but without being able to tie it back to an individual household.
As you mentioned, the project was recently launched with LF Energy. How mature is it? Just give us the state of the project at this point.
Yeah, so we launched the project last month, and we don't actually have the kind of open source technology in place yet. And the reason for that is we wanted to build the community first, get all the interested parties so that we could find the right technical contributors to the project for the next phase. And so going into the rest of this year, we're going to be building out the technical infrastructure to host the algorithms and synthetic data itself. But we're also working on building a set of standards around the synthetic data that will be able to kind of measure the how useful and how private the data is before launching it, so that that's all in place, ready to go.
So the stage right now is building the community, and when we look at OpenSynth, is it going to be software code? Is it going to be specifications, or is it going to be standard?
Yes, all of that. So we're going to be we're going to have a big data repository, which will have various synthetic data sets for various use cases that have been trained on companies' raw data. We're going to have a code repository which will host the algorithms. And the idea here is that we'll have some technology in place that will be able to benchmark the algorithms against public data sets and the metrics that we've come up with, so that we can measure the algorithms and see how suitable they are for different use cases. And we'll also be developing the standards around privacy and fidelity, which will kind of help benchmark those algorithms.
And of course, since it's going to be part of LMRG, it will be all open source. How important is open source for Center of Net Zero?
OpenSynth is our first sort of foray into open source as an organization. We as a research institute, we do try to put all the work that we do in the public domain, and we publish all the work that we do. But in terms of actually contributing to open source, we have a few of our own small contributions, but this is the largest sort of piece of work we've done in collaboration with an open source foundation.
What kind of use cases you are either envisioning, or as you're building a community, when you work with folks from different organizations, these kind of use cases they are bringing to OpenSynth?
So we already have an alpha tool in place where people can download synthetic data from our algorithm, Faraday. And that is already being used across a number of academic institutions and industry organizations. And they're using it for various things. So modeling grid regions, looking at kind of impact of tariffs and impact of solar and weather on the grids. But we think that there are many use cases, especially thinking about future energy systems. One of the benefits of synthetic energy data is that you can control what data is being generated. So we can simulate what we think the future grid will look like, and then try and understand some of the challenges associated with that.
When we look at Center of Net Zero, and we look at other players in this space, what kind of collaboration is there where even if it's a totally different kind of market, but you see a lot of common ground, and what role LF Energy is playing in bringing all these players together?
Yeah, so thinking back to synthetic data, the Faraday tool that we generated is at the moment very UK centric, because that's where we have the largest source of data. But the goal for us in creating OpenSynth is to globalize this, to get more and more people involved. I think what's really important to us for the OpenSynth community is to get people from around the world to be generating and sharing their data from many different countries, so that we end up with a pool of synthetic data that's not only a large pool that will accelerate research as quickly as possible, but also a diverse pool of data, really representing populations around the world and their energy consumption.
And just to add to that, there's no one-size-fits-all solution for this. So our algorithm is good for a specific use case. Other people are working on algorithms for other use cases, and we're in conversation with them at the moment. And that's one of the reasons we want to host all of the algorithms in one place, is because they can be people can take them and adapt them to their specific market conditions.
When we look at energy sector, when we look at LF Energy, we do talk a lot about these, collaboration technologies that are solving problem for mostly energy, sector. But when we look at, the much bigger picture, we talk about climate crisis, which is becoming a really important topic, because the places where used to snow, where it was desert, is snowing and raining. What role do you see project like OpenSynth, even if the project is looking at a specific problem, will deal with this, the much bigger problem that we're looking at?
Yeah, great question. One of the things that we know is really important is that the world is changing quickly, right? And energy systems are changing quickly. Part of that is weather. Part of that is the change to the wider energy system in terms of bidirectional energy flows, distributed energy, changing consumption profiles from weather, but also from low carbon technologies people are using, and a whole bunch of factors are really changing that. And so what we hope from synthetic data and from OpenSynth is to embed some of our thinking on what the future looks like in that data so that we can accelerate research and accelerate the transition as quickly as possible by using data that is not only up to date with the most recent kind of sources of data, but is also encompasses what we think of the future. So for us as a research institute, we do lots of global research to understand what future behaviors will look like from a consumer perspective. So we run global field trials and large scale analyses. And what we hope to do is embed the insights and learnings from that research within the data, such that when it's used in modeling to plan that future global energy system, we're already looking at where we think the future is going and for that to represent it accurately.
What kind of stress or strain just the EV charging is going to play when people are plugging in every night? And what kind of projects, what kind of development you're seeing from the energy sector? Because one day it will become a big problem.
Yes, yeah. So I think especially with the change in supply in terms of renewable energy, that's varying, that makes supply more variable. But then with electrification, like electric vehicles, that increases demand, changes peak demand and what that looks like. And so we need to work out how to balance these things as best we can. And this is where we need really great modeling to really work out how do we match demand and supply. And we also need really great research to understand how consumers will behave. So how will electric vehicles change consumption patterns? And what can we do to help demand and supply balance equally? So one of the focus of a lot of our research areas and our field trials is in demand flexibility. Right? Can we shift users' consumption patterns? Can we charge their electric vehicle overnight when grid constraints are low rather than at peak times and so on? And this is a big part of our research and where we focus not only our trials but also our modelling efforts. Can we embed the insights from that research into our modelling so that we can model that future grid that balances demand and supply appropriately?
It's a big problem, but it's also a really big opportunity, not only to kind of optimize the grids and make it the electrons flowing as optimal as possible, but also for households themselves to benefit from the energy transition if they have these assets and they can be flexible when they can be plugged in, and there's a chance for some of that kind of benefit to flow down to that level.
Are you seeing any projects which are leveraging AI, Gen AI, for those kind of predictions also, or to prepare the grid?
Yeah, I think technologies like AI are going to be incredibly important for optimizing the grid and for making things work. Faraday, as we've talked about, our tool is a generative AI model that can produce synthetic consumption data that looks just like real data. So I think, and that's one space where we'll accelerate research. I think that's really important. But I think there are also many other technologies that can help with this. Automation is going to be hugely important. So I think consumer engagement and flexing demand to match supply is going to increase in importance. And part of that may be manual engagement from consumers. Part of that will be automation. I think automation will grow and grow in its importance. So for things like charging your electric vehicle, let's automate when that happens. So it happens at times that not only meet grid constraints, but also meet the consumer's requirements of having their vehicle charged when they need it. The same with heating and heat pumps and cooling with air conditioning. Can we automate how and when these consume energy whilst meeting the thermal constraints of customers? And these are just a small set of examples. There are many, many uses of technology like AI that I think will only grow in importance as the transition continues.
As you're saying that you're building the community, I have a couple of questions. Number one is that what kind of community is already there around the project OpenSynth? Second is what kind of community you want to build? And number three is how people can get involved.
OpenSynth has three main goals, I think. Firstly, we want to build a one-stop shop where users of synthetic data and generators of synthetic data can come together and access the data, access the algorithms, discuss and share best practices, technical know-how, use cases, benchmarking, all of those kind of things in one place. So that's goal number one for the community. Goal number two is to encourage more and more people to generate and share synthetic data to accelerate research for everyone else. So we want as many people to get involved as we can in sharing their data if they have access to that. And then thirdly, it's encouraging more and more people to use synthetic data, whether that's academic researchers, commercial organizations, systems operators, governments. The more people that are using the data, the faster and cheaper we can make the transition happen. In terms of getting involved, do you want to talk about getting involved?
Yeah, I mean, so currently we have a number of users using the data and adding it to their research. We've got a smaller number of users who are working on their own algorithms to generate synthetic data. And we have an even smaller number of users who have the raw data already ready to train on. So it's those latter two that we need to grow immediately, as well as the kind of just general knowledge of synthetic data and how it can be used and why it's important for policy and decision making. To get involved, we have a mailing list that you can join, and we will be kind of starting to set up like committees and the kind of technical next steps throughout the year to kind of start building this the technology and community out.
We're really keen for as many people to get involved as possible, whether that's to contribute to the research, to the development of the algorithms, to defining what useful use cases are for synthetic data, or even those that just want to come and pay attention to what we're doing and keep an eye on things. So the more people that can join the mailing list, the better. And we'd really love to have as many people as possible come and join the community.
And what kind of people should join it?
So we are particularly interested in those that have access to raw smart meter data themselves, so that they can then use the existing algorithms to generate and share their own data and build up that pool of synthetic data. We're also interested in those that can benefit from using synthetic data to advance their use cases themselves. So policymakers and governments and systems operators would all be very welcome, but even academic researchers, commercial organizations, we're interested in everyone playing their part.